Let's see this question. This question is asked in GATE 2013, the subject analog. Okay. In the circuit shown below, the op amps are ideal. Then V out in volts is, okay, this is the given circuit with two op amps. Let this can be op amp 1 and this can be op amp 2. Okay. Now they are asking to find out what is the value of V out. The given op amp 1 and op amp 2 are ideal. If you observe in op amp 2, here we are applying actual input for only positive voltage, positive terminal, that is non-inverting terminal, and the other terminal is connected to ground. So op amp 2 is called non-inverting op amp. Op amp 2 can be considered as non-inverting op amp. Non-inverting op amp, because we are applying actual input to the positive terminal. Then we can write V out as let this is the point where we are applying actual input. This can be called as VO1. Okay. Now V out equal to 1 plus RF by R1 into VO1. Okay. This is RF, this is R1. Now substitute the values of RF and R1, 1 kilo and 1 kilo. That is equal to 1 plus 1 by 1 into VO1. Okay. This for this entire thing, that is equal to 2VO1. So V out is equal to 2VO1. Let this can be equation 1. So if we calculate VO1 and multiply by 2 times, we will get the required value V out. Okay. Now if you observe here in this op amp 1, here we are giving inputs to two terminals. For non-inverting terminal plus, we are applying plus 1 volts. For inverting terminal, we are applying minus 2 volts. So we cannot say directly whether this op amp is inverting or non-inverting. For that, we need to apply superposition theorem. Okay. What this superposition theorem is states that superposition theorem. Okay. What this superposition is states is apply one voltage at a time, remaining other voltage can be grounded. Finally, you can calculate all the responses. Okay. So first we need to make apply minus 2 volts at the time plus 1 volts is grounded. So don't consider it. And then this op amp act as inverting op amp. Then don't consider this. Consider plus 1 volt which is giving to non-inverting terminal. So this can be act as non-inverting op amp. So finally add up all the responses, you will get VO1. Okay. Now what this states is consider one voltage at a time. Consider one voltage at a time. Okay. Then add all the responses. Add all responses. Now here we have two things. So VO1 equal to VO1 if we consider minus 2 volts plus VO1 if we consider plus 1 volt. Okay. These two we need to find separately. Okay. Now VO1 due to minus 2 volts. If you apply minus 2 volts, okay, at this time this is grounded. So it is said to be inverting op amp. So op amp 1 act as inverting op amp. For inverting op amp, we can calculate VO1 equal to minus RF by R1 into Vin. Okay. So this is RF, this is R1. So minus 1 by 1 into input is minus 2 volts. Okay. This will be minus into minus becomes plus, this will be plus 2 volts. VO1 due to minus 2 volts is 2 volts. Now we will calculate VO1 due to minus plus 1 volt, that is equal to, if you consider this plus volt, this will act as ground. Okay. This will act as ground. Now it is connected to non-inverting terminal. So this will act as non-inverting op amp. Non-inverting op amp. So for this we can calculate VO1 is equal to 1 plus RF by R1 into Vin. is equal to 1 plus, so RF is 1 kilo ohm and R1 is also 1 kilo ohm, 1 by 1 into V in is plus 1 volt. Okay, this is equal to 1 plus 1, 2 into 1 volt, that is equal to 2 volt. So VO1 due to plus 1 volt is 2 volts. So substitute here, this will be 2 plus 2, that is equal to 4. Finally, VO1 we will get 4 volts. Substitute this in equation 1. Substitute in equation 1. Okay. So equation 1 is here. You substitute that value. VO1 is equal to, so Vout equal to 2 times of VO1 equal to 2 times of VO1 is 4 equal to 2 4s are 8 volts. So finally we have got the equation of Vout, that has 8 volts. So in the options, option C is the correct answer.